Okay, today I am going to discuss about the Lewis dot structure. It is also known as Lewis electron dot structures. Electron dot structure. Electron dot structure. Electron dot structure, or also Lewis structures. Lewis dot structure basically talks about or shows basically bonding between atoms in a molecule and lone pair of electron if lone pair of electron exist. Suppose we have to draw the Lewis dot structure of SO4 minus 2. We have to draw the structure of Lewis dot structure of SO4 minus 2 or PO4 minus 3 or CO3 minus 2, ClO4 minus ClO3 minus BO3 3 minus PCl3 PCl5 SO2 sulfur dioxide SO3 carbon dioxide. We will just use simple trick and some rules to draw all the structure at it. In order to draw the structure for SO4 minus 2 or PO4 minus 3 or CO3 minus 2 or ClO4 minus or all the structure, we will follow some rules, and from that rules we can easily draw the Lewis dot structure. Okay, first let me explain about the rules. What are the rules to be followed to draw the exact Lewis dot structure of these molecules? Okay, so rule number 1. Rule number 1. First, we need to find the central atom. So, first rule is we need to find central atom. We must find central atom. Central atom should have or should be list number lowest electronegativity list number, lowest electronegativity, and larger in size. Larger in size. you must remember that hydrogen and fluorine cannot be a central atom. হাইড্রোজেন और ফ্লোরিন কখনো সেন্ট্রাল অ্যাটম হবে না। কারণ কি ভাই? হাইড্রোজেন it forms maximum one covalent bond. Fluorine also can form one covalent bond. Fluorine can form only one covalent bond. Okay, this is the rule number 1. So for example দেখা যায় যে SO4 minus 2, what will be the central atom? Central atom এখানে হবে ভাই, central atom will be sulfur, will be the central atom, কারণ সালফার লিস্ট নাম্বার, এখানে অক্সিজেনের 4টে আছে, সালফার is only 1. Lowest electronegativity in comparison, if we compare the electronegativity of sulfur and oxygen, sulfur has lower electronegativity than oxygen. Okay, larger in size of sulfur is larger compared to size of oxygen. So okay, so here sulfur will be the central atom. 2. Rule number 2. Count total valence electron. Count total valence electron, including charge. নেগেটিভ হলে অ্যাড করব, পজিটিভ হলে সাবট্রাক্ট করব, মানে count total valence electron including charge. Here what will be the total valence electron in case of SO4 minus 2? Total valence electron is basically 6 plus 4 multiplied by 6 plus 2. This 2 comes from charge, so this will be 30. So total valence electron we will count, and in this case it is 32. Now step 3, rule 3. If total valence electron is multiple of 8, then central atom won't have any lone pair of electron. যদি total valence electron 32 হয়, if total valence electron becomes, in this case 32, if total valence electron becomes multiple of 8, there won't be any lone pair of electron on central atom. In the case of SO4 minus 2, there will be no lone pair of electron on sulfur, because 32 is multiple of 8. Okay, now rule number 3. What will be the formula for counting the lone pair of electron? Lone pair একটা formula আছে, যে lone pair of electron এর formula আছে ভাই total valence electron minus 8n divided by 2. Total valence electron minus 8n divided by 2. Or else you can do one thing, that whatever total valence electron you will get, in this case total valence electron equal to 32, just simply divided it by 8. If there is no remainder, means there is no lone pair of electron on sulfur atom. Or else we can use this formula. How? See, total valence electron in this case 32 minus 8 into n. N is basically number of bonded atoms. Here number of bonded atoms are 4. So 4 divided by 2, that will also give you 0. What does it mean? It means that SO4 minus 2, in SO4 minus 2, there is no lone pair of electron on sulfur. On sulfur. Okay. Now rule 4. See, whenever we will draw the Lewis-Strauss structure, what we have to do, we have to check how many number of sigma or pi bond, how many number of sigma or pi bonds are there and lone pair. Sigma bond count করব কিভাবে? Number of sigma bonds equal to total number of atoms minus 1. Here total number of atoms হয় কত? 4 থেকে 5. So 5 minus 1, that will give you 4. So in SO4 minus 2, there will be 4 sigma bonds. Now let's count number of pi bonds. How to count the number of pi bonds? See, there is one formula that bonds equal to valence electron of central atom minus lone pair electron. Valence electron minus lone pair electron. Valence electron of central atom. So how we can calculate the number of pi bonds in case of SO4 minus 2? See, bond means sigma plus pi is equal to valence electron 6. So 6 lone pair of electron by lone pair of electron 0. There is no lone pair of electron. Already we have counted that sigma bonds are 4. So you just put 4 plus pi is equal to 6. So number of pi bonds will be 2. Okay. So number of pi bonds will be 2. This is rule number 5. So what we did, we basically counted how many numbers of sigma bonds are there, how many numbers of pi bonds are there, how many numbers of lone pair of electron on central atom is there. These we have calculated. Okay. Next, we need to now calculate formal charge. Suppose a molecule is like AB4. There is a molecule like AB4. Or say, okay. If B has a covalency 1, if B has covalency 1, then there will be no formal charge on B, because B only form one bond. Okay. Now how about A? If A has covalency 3, but it forms 4 bonds. it forms 4 bonds. Then it will have formal charge positive. And if it forms less than 3 bonds, then it will have formal charge negative. It will form less than 3 bonds. Less than 3 bonds. Maniki, let me take you one example. J. Suppose NH4 nitrogen covalent theme. Nitrogen here forms 4 bonds. Here form 4 bonds. So it will have a formal charge positive. Likewise, oxygen. Say A single bond oxygen O. Oxygen form usually 2 bonds. So here it will have formal charge negative. It will have formal charge negative. If let me take you some example of let me give you some example on formal charge. Say we have a compound molecule like N triple bond N single bond N. Suppose this is the one. Here there won't be any formal charge because nitrogen has a covalency 3 and it forms 3 bonds with this nitrogen. And for this nitrogen, plus charge, because nitrogen form here 4 bonds. In this case, nitrogen will have -2 formal charge. Okay. In case of C double bonded CO3 minus 2, say CO3 minus 2. This is the structure of CO3 minus 2. Now, formal charge of oxygen here it will be minus, here it will be minus. Why? Because in this case, oxygen form actually 2 bonds with carbon. So, this oxygen won't have any formal charge. However, on this oxygen there will be a formal charge that is negative, and in this oxygen also formal charge negative. If SO4 minus 2, say SO4 minus 2, in this case oxygen will have minus, in this case oxygen will have minus. Sulfur can form maximum 6 bonds, 1, 2, 3, 4, 5, 6, and this sulfur is basically expanded octet. Why? Because it has lower energy d orbital. Okay, if you talk about PO4 minus 3, say PO4 minus 3, double bonded O. This is PO4 minus 3. So what will be the formal charge on element? Minus, no formal charge. Now how about the formal charge on sulfur? So we have to apply, or we have to follow a formula. That formula is formal charge is basically formal charge equal to valence electron minus number of bonds plus lone pair electron. So what will be the formal charge of the sulfur? Sulfur has valence electron, 6 valence electron. Number of bonds, how many bonds? 1, 2, 3, 4, 5, 6, 6. It has no lone pair of electron, 0. So sulfur has no formal charge, it is 0. How about this oxygen? Oxygen here, I will show you later. Oxygen has 2 lone pair of electron. So on this oxygen, formal charge is basically valence electron, 6 valence electron minus number of bonds 2. Lone pair of electron 1, 2, 3, 4, 2 pair of electron, so 4. So 0. So there won't be any formal charge on this oxygen atom. How about this one? here 2, 4, 6. 6 electron on this oxygen. 3 pairs of electrons. So formal charge, we can write formal charge here. Formal charge of this oxygen, formal charge of this oxygen is basically valence electron 6 minus of lone pair of electron 1, 2, 3, 4, 5, 6. 6 and number of bond 1. So 6 minus 7, that will give you minus 1. So minus 1. What I am trying to say, if an element, if its maximum covalency, whatever its covalency, or whatever the number of bonds, usual bonds it forms, if that many number of bonds are being formed with element, with central atom, then it won't carry any formal charge. Oxygen valency, maximum covalency 2, oxygen will form 2 bonds, so it has no formal charge, no formal charge, no formal charge. Here formal charge, here formal charge. Okay. So this is about the formal charge. So these are the formulas. Based on these formula, we can draw any Lewis dot structure. Any Lewis dot structure. Okay. Let me write here. So count PVE. If multiple of 8, multiple of 8, no lone pair of electron, sigma bonds equal to number of atoms minus 1, total number of atoms, total number of atoms minus 1. Bonds equal to the valence electron minus lone pair electron, okay, and what else? And from that we can calculate the pi bonds, number of pi bonds. Last one, the formal charge equal to valence electron minus lone pair electron plus bonds. Based on this formula, we can draw any Lewis dot structure at each. Quite simple. Giacomo Lewis dot structure we can easily draw from this formula. But you must remember one thing. যখন লুইস ডট স্ট্রাকচার ড্র করব তখন সেন্ট্রাল অ্যাটম মাস্ট ফুলফিল octet or more than octet. See, in order to get the best Lewis structure, we will fulfill the octet of bonded atoms as well as central atom as much as possible. সব ক্ষেত্রে হবে না, it won't follow in each case. In some of the cases it may or may not follow. In some cases it will expand octet for hypervalent atoms. Okay, based on this formula we are going to now draw the Lewis structure. Okay, start with SO4 minus 2. Start with SO4 minus 2. SO4 minus 2. Okay, for example, count total valence electron. This is the first rule. So total valence electron count by total valence electron. What are the total valence electron? Total valence electron here 6 plus 4 multiplied by 6 plus 2, that is 32. Okay. Is there any lone pair of electron on sulfur? No, because this is multiple of 8. So no lone pair of electron on sulfur. মানে সালফারের উপর কোনো lone pair of electron নেই। আচ্ছা, before that one more thing I write, that central atom here is sulfur is the central atom, because কারণ সালফার হচ্ছে lowest electronegative, larger in size, least number, একটাই আছে। Next, now count number of sigma bonds কত? number of sigma bonds এর ফর্মুলা কি? number of sigma bonds এর ফর্মুলা by total number of atoms minus 1. The formula for number of sigma bonds is total number of atoms. Total में 4 और 5 means 4 plus 1 5. So 5 minus 1, that will give rise to 4. So 4 sigma bonds are there. Now how many numbers of pi bonds? Pi bond okay, there is one formula, bonds equal to valence electron minus lone pair electron. Valence electron of what? Valence electron of central atom or valence electron. So bonds katu? So bonds means sigma plus pi. Valence electron of 6 minus 0 is equal to 6. Now sigma bond already we know, 4 sigma bonds. So 4 plus pi equal to 2. 6. 6. So pi bonds are 2 pi bonds are there. These are the points. Now I will draw the structure of SO4 minus 2. We got all the informations except the formal charge. Formal charge I will show at the end. Except formal charge, everything we have got. Okay. We'll draw the structure here. Draw the structure here. To draw the structure, okay, sulfur is the central atom. 4 bonds, sulfur form 4 bonds. So 4 bonds, form 4 bonds, 4 sigma bonds. Oxygen. 2 pi bonds. Now these 2 pi bonds you can put or form either here or here or here or here. It does not matter. আমি করে দিলাম এখানে। I will do it like this. Now oxygen will have electron like lone pair electron 1 2 3 4. So 2 pair of electron, this oxygen 2 lone pair of electron, and this oxygen 1 2 3 4 5 6, and here 1 2 3 4 5 6. Previous slide I have shown that in the previous slide I have shown that in previous page I have shown that it does not carry any formal charge equal to 0 by এখানে কোনো formal charge নেই। ফর্মুলা কি? formal charge equal to valence electron minus lone pair electron plus bond. So if you put the valence electron 6, lone pair 1 2 3 4 4, bonds 1 2. So there won't be any formal charge here. There is no formal charge. Here formal charge is there. কত valence electron 6 minus 6 plus 1, that will give you minus 1. So minus 1 and minus 1. This is the Lewis dot structure of SO4 minus 2. This is the Lewis dot structure of SO4 minus 2. Now count the total electrons. Okay, total electrons 32. কতগুলো electrons? 32 electrons. So 30 electron count করে দেখা যাক. Let me count. Okay. 6, 8, 10, 12, 14, 16, 18, 20. For this bond, 22, 24, 26, 28, 30, 32. So this is the Lewis dot structure of SO4 minus 2. This is the Lewis dot structure of SO4 minus 2. Like that way, we can draw any Lewis dot structure. Any Lewis dot structure, just following these formulas. There are some other ways people do it, but for me, this is the best one. This is the best one. Okay. Now, let me show you another example. CO3 minus 2. Okay. CO3 minus 2. CO3 minus 2. কি করব? Central atom কে দেখব। ভাই central atom কি? What is the central element? Central element. Of course, carbon. Carbon is the central element. List number, list electronegativity. Central. Larger in size compared to also. Now count total valence electron. Total valence electron কত? Total valence electron 4. 4 plus 3 into 6 plus 2. You cannot resolve by 2. 24. So this is multiple of 8. Multiple of 8. Multiple of 8. Means no lone pair of electron on carbon. Carbon upon কোনো lone pair of electron নেই। আচ্ছা, যদি এটা বুঝতে অসুবিধা হয়, you do just one thing, you divide it by 8. Then 8 3s are 24. No remainder means no lone pair. Now number 3. Number of sigma bonds. Sigma bonds equal to total number of atoms. কতগুলো atom আছে? 4 minus 1. Sorry, minus 1. So that will give you 3. So 3 sigma bonds are there. Now, are there any pi bonds? Pi bonds, that is a pi bond আছে কি? Okay, sure. Pi bond. Bonds equal to valence electron 4 minus lone pair electron 0. So 4. This bond basically sigma plus pi. Sigma plus pi equal to 4. So pi bond equal to sigma already known 3. So pi bond 1. And একটা pi bond. হলো একটা pi bond. What else? Now formal charge আছে কিনা দেখছি। Now draw the Lewis structure. Lewis structure. C oxygen. 3 sigma bonds. 1 pi bond. This pi bond you can put anywhere, here or here or here, because it will have resonating structure actually. So double bond done. The structure is done. এখন এখানে ভাই কোথাও কি কোনো ফর্মাল চার্জ আছে? অফকোর্স এই অক্সিজেনের মধ্যে একটা ফর্মাল চার্জ, এই অক্সিজেনের মধ্যে একটা ফর্মাল চার্জ আসবে। কেন ফর্মাল চার্জ আসবে? কারণ অক্সিজেন এখানে কার্বনের সঙ্গে একটাই বন্ড ফর্ম করছে। কার্বন অক্সিজেন ফর্ম only one bond with carbon. That's why it will carry formal charge. It will also carry formal charge, but it does not carry any formal charge. Okay. তাহলে এখানে ইলেকট্রন কতগুলো থাকবে ভাই? ইলেকট্রন See, অক্সিজেনের 6টা ইলেকট্রন, অক্সিজেনের 6 ইলেকট্রন, see 1 2 3 4 5 6, and this oxygen 2 4 6. বল স্যার আপনি কি করে জানলেন এখানে 6 ইলেকট্রন আছে? by oxygen form one bond, it will carry a formal charge, so total it will have 7 electron. 1 2 3 4 5 6 7. oxygen একটা electron used for this bond, right? so 1 3 5 7, এখানেও তাই 2 2 4 6. this is the structure. কার্বন কি অক্টেট ফুলফিল করেছে? এবার লাস্ট স্টেপ দেখা যাক whether this is the valid structure. This is the valid structure or not. See, whenever in Lewis structure, if all the elements fulfill octet, you can say that that is the best Lewis structure. Best Lewis structure, because there will be several possibility. I'll show you later. There will be several possibility, or not this structure. There are some other lots of structures are there. You will have 2-3 possibilities, means resonating structure. From that you need to tell the best one. After, I mean, check the formal charge, octet. So carbon 2 4 6 8 fulfill octet, 8 electron fulfill octet. This oxygen 2 4 6 8 fulfill octet, 8 electron. This is also 8 fulfill octet. This is 2 4 6 8 8 electron fulfill octet. So this is the base structure for CO3 minus 2. Again I am telling one thing, that this double bond you can put it here or here, because there will be, this is the resonating structure. I am not showing here resonating structure, or here like this. So কখনো এটা থাকবে ডাবল বন্ড, এটা থাকবে ডাবল বন্ড, এটা থাকবে ডাবল বন্ড, ঠিক আছে? অ্যাকচুয়ালি এখানে -2/3 -2/3 -2/3 ক্যারি চার্জ করবে each oxygen. Each oxygen will carry charge -2/3. So this is the Lewis structure for CO3 minus 2. একটা জিনিস এবার একটা জিনিস, যে SO4 minus 2 কিছু আইডিয়া থাকতে হবে, যে SO4 minus 2 এর আমি যে স্ট্রাকচার ড্র করব, কিছু তো আইডিয়া থাকতে হবে যে কি করে আমার এলো স্ট্রাকচারটা। SO4 minus 2 বা CO3 minus 2, এই মাইনাস দেখে ভাই ঘাবড়ে গেলে হবে না। ডোন্ট গেট প্যানিক জাস্ট বাই লুকিং at this minus charge. এই মাইনাস চার্জটা করতে গেল কি করব মাইনাস চার্জ নিয়ে? বেসিক্যালি SO4 minus 2 টা এরকম ভাবে ভাবো যে it is coming from say H2SO4. H2SO4. So H2SO4 structure there. That way, if you draw the structure of H2SO4, then you just remove this one, hydrogen. Then it will be C double bond O, O minus. হাইড্রোজেনের যে ইলেকট্রন বা এখানে ছিল অক্সিজেন টেকেট, তাহলে অক্সিজেনের টোটাল কতগুলো ইলেকট্রন থাকবে? 2 2 4 6 আর একটা 7, একটা ইলেকট্রন অ্যাকসেপ্ট করেছে কারণ এখানে +2 H প্লাস আছে। CO3 minus 2 এর ক্ষেত্রে কি হবে? CO3 minus 2 এর ক্ষেত্রে এক্স্যাক্টলি তাই, H2CO3 কার্বনিক অ্যাসিড, H2CO3 প্রোটন রিলিজ করে দাও, কি আসবে? C ডাবল বন্ডেড O minus 2 4 6 2 4 6. That's all. This is the Lewis structure. Now let me show the Lewis structure of PO4 minus 3. PO4 minus 3 structure here. PO4 minus 3. কি করব? প্রথম কি সেন্ট্রাল অ্যাটম কে central atom, central atom is phosphorus. Only one electronegativity less, size is bigger. Total valence electron level, 5 plus 4 multiplied by 6 plus 3, that will give you 32. Okay, total valence electron. Sigma bond কত? Sigma bond কত? Sigma bond by 4 के 5 means 5 minus 1, so 4 sigma bonds. Pi bond কত? See, bonds equal to valence electron minus lone pair electron. See, 32 is multiple of 8. 32 is multiple of 8. Means no LP on central atom. So bonds equal to valence electron minus lone pair means sigma plus pi equal to 5. Sigma already known, so pi equal to 5 minus 4, 1. So 1 pi more. Later we will put the formal charge. 3 formal charge will be there. Minus 1, minus 1, minus 1 on each oxygen. See, first of all, it is coming from H3PO. Okay. Now, let me draw the Lewis structure of PO4 minus 3. So, phosphorus is the center. It forms 4 sigma bonds with oxygen. Okay, 1, this is 2, this is 3, this is 4. 4 sigma bonds. Now, how many pi bonds? Only 1 pi bond. You can put it anywhere, whether here, it does not matter. তিনটে চার্জ আছে কি না? তিনটে ফর্মাল চার্জ। এই অক্সিজেন ফর্মাল চার্জ পাবে, এই অক্সিজেন ফর্মাল চার্জ পাবে, এই অক্সিজেন ফর্মাল। কেন হবে? Because oxygen forms only single bond with phosphorus. Okay. So now you just put electron over here. 2, 4, 6. 2, 4, 2, 4, 6. 2, 4, 6. Okay. If you count the, see, phosphorus, it won't have any formal charge. Here formal charge is 0, right? Formal charge is equal to 0. Can formal charge 0? By formal charge formula, valence electron minus number of bonds 1, 2, 3, 4, 5. So 5 bonds plus lone pair electron 0. So formal charge 0. So it won't carry any formal charge. So structure is done. PO4 minus 3. This structure is done. Now, if you count the total number of electrons, how many numbers of electrons? 32. 32 you just count. See, 6, 18, 20, 22, 24, 26, 28, 30, 32. So 32 electrons are there. Octet. 2, 4, 6, 8 fulfill. 2, 4, 6, 8 fulfill. 2, 4, 6, 8 fulfilled. 2, 4, 6, 8 fulfilled. How about phosphorus? 2, 4, 6, 8, 10. Alright. Phosphorus has 3d orbital. So it will have expanded octet. For sulfur also, it will have expanded octet. It may or may not. Phosphorus, expanded octet. Carbon, never. Because it doesn't have a d orbital. Lower energy d orbital. Okay, so this is the Lewis structure of PO4 minus 3. See, for Lewis dot structure and Lewis structure, I'll explain just in a minute after some. Now next, move to sulfur dioxide or ClO4 minus. First let me draw ClO4 minus. See, ClO4 minus. What will be the Lewis structure of ClO4 minus? Lewis structure. Central atom की central atom, total valence electron, total valence electron 7 plus 8 plus 36. Total valence electron 36. Now count lone pair of electron. In order to get lone pair of electron, you just divide it by 8. Sure, both please. Sure. 2 lone pair. No. Sorry. Silly mistake. This is basically 24. This is basically, so sorry, 24, 32. This will give you so 32. So no lone pair of electron. Sorry. No lone pair of electron. So lone pair of electron, multiple of 8, 0. Sigma bonds, sigma bond कतो 4 रखे 5. So 5 minus 1, that will give you 4 sigma bonds. Number of pi bonds, see, same formula. Bonds equal to valence electron 7 minus lone pair 0 is equal to 7. So pi bonds, sigma plus pi equal to 7. Pi bonds equal to 3. So 3 pi bonds. 3 pi bonds, 4 sigma bonds. At oxygen for formal charge. At oxygen for formal charge. And done. Now try to draw the structure. Okay, Cl center. How many number of sigma bonds? 4 sigma bonds. Okay, 1, 2, 3, 4 sigma. 3 pi bonds. 1, 2, 3. That's all done. Cl can form maximum 7 bonds. 1, 2, 3, 4, 5, 6, 7. 7 bonds. Now put electron pair, lone pair of electron. And this will carry formal charge. So 2, 4, 6. This is the Lewis structure of ClO4 minus. See, octet fulfilled. 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 2, 4, 6, 8, 2, 4, 6, 8. Here 2, 4, 6, 8, 10, 12, 14. No problem. It has d orbital. It has lower energy d orbital. So it will have max expanded octet. So this is the Lewis structure of ClO4 minus. It where does it come from? It comes from basically HClO4 minus. HClO4 minus parachloric acid. Parachloric acid is, sorry, let me draw it here. Parachloric acid H O Cl double bonded O double bonded O double bonded O. This is the perchloric acid. This is acid. It will release proton and it will form Cl4 minus. This is the Lewis structure of Cl4 minus. Now next, if we need to draw the Lewis structure of, আচ্ছা এখন পর্যন্ত formal charge দেওয়া Lewis structure গুলো দেখালাম. Till now I have shown the Lewis structure with element carrying formal charge. Now I am going to show some Lewis structure without any formal charge. So neutral. Sulfur dioxide SO2. Sulfur dioxide. Sulfur dioxide central atom to sulfur. Total valence electron 6 plus 2 multiplied by 6, that will give you 18. So is there any lone pair of electron? Yes. 18, 16, 2, 2, 1. One lone pair of electron. One lone pair of electron, confirm. One lone pair of electron. Now 3. Sigma bonds. Sigma bonds is equal to 2, 1, 3. So 3 minus 1, that will give you 2. 2 sigma bond. Is there any pi bond? Pi bond ki ache? Pi bond. Okay. Bonds equal to valence electron 6, lone pair electron it's 2, it's 4. So pi bonds is equal to sigma plus pi equal to 4. So pi bonds 2. So 2 sigma 2 pi. Done. 2 sigma 2 pi. Structure down. Sulfur 1 sigma 2 sigma 2 pi 2 pi. Lone pair of electron. Here, that is the structure. This is the structure. Oxygen fulfill up it. Okay. We must show the lone pair of electron. Lone pair of electron. Oxygen 2, 4, 6, 8. 2, 4, 6, 8. Sulfur 2, 4, 6, 8, 10. No problem with sulfur. No problem with sulfur. It will have expanded octet. So this is the Lewis structure for sulfur dioxide. Sulfur dioxide. How about carbon dioxide? Carbon dioxide Lewis structure here. Carbon dioxide. Okay. Carbon dioxide. Carbon dioxide. CO2. Central atom. Carbon. Central atom. Carbon. Total valence electron 4, 12, 16. Okay. Lone pair of electron? No lone pair of electron because it is multiple of 8, right? No lone pair of electron in it. There is no lone pair of electron on carbon. Next. Sigma bonds. Sigma bonds. What is the formula? Sigma bond 2, 1, 3. So 3 minus 1, that will give you 2. Pi bonds. Pi bonds. How to calculate pi bond? Bonds equal to sigma plus pi equal to valence electron 4 minus lone pair 0. So pi bond 2 pi bond. So we have solved that. Sigma bond 2, pi bond 2. No lone pair of electron. Carbon is the central atom. What else you need to draw the structure? Nothing. কোনো formal, কোনো charge নেই এখানে। এখানে কোনো formal charge নেই। তো draw করো। C 1 sigma 2 sigma 1 pi 2 pi lone pair 1 2 1 2 1 2 1 2. This is the structure for carbon. এখানে প্রত্যেকটা এলিমেন্ট স্যাটিসফাইজ অক্টেট। প্রত্যেকটা এলিমেন্ট কিন্তু অক্টেট স্যাটিসফাই করেছে। দেখ 2 4 6 8 2 4 6 8 ক্লিয়ার 2 4 6 8 দিস ওয়ান 2 4 6 সরি 2 4 6 8 2 4 6 8 okay carbon also 2 4 6 8 so this also fulfill octet this one also octet this one also octet every element here satisfies octet rule means total electron surroundings the element are 8 carbon dioxide structure for carbon dioxide restructure. Now how about sulfur trioxide? Let me draw sulfur trioxide SO3 SO3 structure क्या है? Okay, central atom में sulfur, total valence 6 plus 3 multiplied by 6, that will give you 24. So lone pair of electron 0. Sigma bonds basically 3 1 4, so 4 minus 1 is equal to 3. Pi bonds sigma plus pi equal to 6 minus 0, so pi bonds are 6 minus 3, that will give you 3. Now let me draw the structure. Okay, structure draw कर दे. Sulfur 1 1 1 1 sigma oxygen. Now pi 3 pi 1 pi 2 pi 3 pi. Now put one pair of electrons. Done. See, oxygen 2 4 6 8 2 4 6 8 2 4 6 8, sulfur 2 4 6 8 10 12, no problem, not at all issue. Sulfur can expand its octet. So this is the Lewis structure for sulfur trioxide. Formal charge এখানে কোনো formal charge থাকবে না কেন formal charge means valence electron minus number of bonds 1 2 3 4 5 6 plus one pair of electron 0 so 0 এখানেও 0 formal charge 0, here also formal charge 0. Okay, let me show you the Lewis structure of say BF3. What will be the Lewis structure of BF3? BF3 Lewis structure. Okay, boron central atom, total valence electron কত 3 plus 3 multiplied by 7, that will give you 24. Lone pair of electron 0 because it is multiple of. Okay, sigma bonds 4 minus 1 equal to 3. Pi bonds sigma plus pi equal to boron 3 electron 3 minus 0, so pi bond is equal to 0, so there is no pi bond. That's all done. We can now easily draw the Lewis structure. Right now let me draw the Lewis structure of BF3. Okay, boron sigma bond কত number of sigma bond 3, no one pair of electron 4, 6 because fluorine has 7 electrons in its valence cells. So 2, 4, 6 and 1 electron used for this sigma bond with boron. Here also 2, 4, 6, 7, 2, 4, 6. This fulfills octet. Fluorine octet fulfill করেছে, এখানেও fluorine octet fulfill করেছে, এখানেও fluorine octet fulfill করেছে. Here fluorine fulfills octet, here also and here also. How about boron? Boron does not fulfill. It has 6 electrons. It's less than octet. Less than 8 electrons. Means it did not fulfill. This is the structure for Lewis structure for BF3. BF3 does not fulfill. Here boron does not fulfill octet. That's why it acts as basically by Lewis acid. So what I am discussing about Lewis acid. A BF3 it's a very interesting molecule. এখানে back bonding হবে ভাই, back bonding হবে. The পরে discuss later we will discuss back bonding, Lewis acid, Lewis base. Okay. Now let me draw the Lewis structure for one more interesting molecule, that is XCF4. XCF4. What will be the Lewis structure of XCF4? We'll follow the same rule. Okay. Total valence electron. Count total valence electron. Okay. Xenon is the central atom. Total valence electron 8 plus 4 7s are 28, 36. Divide by 8. So 2 lone pair of electron. Done. This will give you the lone pair of electron. Sigma. This is basically sigma. But put this formula like 5 minus 1. That will also give you the same result. So, pi bond. Sigma plus pi equal to sigma plus pi equal to 8. Sigma plus pi equal to 8. So sigma 4 plus pi bonds equal to 8 minus lone pair of electron. 8 minus lone pair of electron means 4 lone pair of electron. 2 lone pair means 4 lone pair of electron. So 4. So pi bonds equal to 0. There is no pi bonds equal to 0. So done. Now let me show you the Lewis dot structure. Xenon, fluorine, sigma, no pi bond, only one lone pair of electron. This is the Lewis structure. For fluorine, 2, 4, 6, 2, 4, 6, 2, 4, 6, 2, 4, 6. So fluorine to be octet. 2, 4, 6, 8, 10. Not at all issue. Xenon can expand its octet. So you can count the total electron. See, 2, 4, 6, 24, 26, 28, 30. No. 2 lone pair of electron. That's all. One more. This is the structure. This is the structure. So 36, 6, 8, 6, 12, 18, 24, 26, 28, 30, 32, 34, 36. Done. This is the Lewis structure of HCl. Like that way, we can draw the Lewis structure at it. But you will face some problems of drawing some Lewis structure of odd electron species, and for that we will use the different rule. Now I am showing for which molecule you can apply the formula which I have now discussed. Next time we will discuss the Lewis structure of NO2, NO3 minus NOCO, O3, NO2 plus SCN thiocyanate minus OCN isocyanate, CNO, CNO. This is very important structure. This is fulminate. Why it is interesting? Because see, your central atom will be nitrogen, not carbon. Okay, azide, N3 minus, azide, okay, N2O3, N2O, N2O5, N2O5, what? Okay. Next time, we will discuss the Lewis structure of this molecule by using a different formula. And you can solve this, or you can draw the Lewis structure at each for this structure, for this molecule at each, and that formula will be different. So thank you so much.